Okay, so yesterday we talked about multi-threading and multi-processing, and then we even discussed about a life cycle of a particular thread, how threads are created, and all that stuff, okay? So today we are going to see about other methods which are there in our thread class, how they are used, when they are used, and what effect they have on the thread life cycle. Now, yesterday, while explaining about the thread life cycle, we missed one state which was called as the blocked state. The thread life cycle was new. When does new state comes? Whenever you create a thread object, okay? Then was your runnable. Okay, when does runnable state come into picture? The moment you invoke a start on a particular thread, it goes into your ready to run pool, or you can say it jumps into the runnable state. Then these two states, that is your runnable state as well as your running state, is interchangeable. Okay, it depends on the thread scheduler when it gives the CPU to a particular thread and it jumps into the running state. This is your dead state. When do you come to the dead state? After the thread has finished execution of the entire run method, it will enter into the dead state. And this one is your blocked state. We did not talk about this blocked state yesterday. We will do that today. What is the blocked state and what happens, or how does a thread goes into a particular blocked state? Now, yesterday, in order to create a thread, what was the method? Before what was the method? How many methods are there in order to create a thread? Two methods. One, creating runnable classes. Second is getting extended from your thread class. So we saw what? We saw creating runnable classes, and we had created one employee.java. Okay. Now, what we are going to do is, we are going to go to test one. Over here, let's create two threads, okay? How do we create a thread? Create an employee object, a runnable interface, a runnable object of employee. Since employee is a runnable class, you need to create an object of employee and then create two threads. Okay, now since we are creating two threads, we'll have to make use of two employee objects, employee E and employee E1. Okay, now make thread T and thread T1. Thread T equal to new thread, thread T equal to new thread, thread T equal to new thread. Pass your first runnable object, that is E, and then let's create another thread, thread T1. This is what we did yesterday. Now, what has happened? On line number 7 and 8, two threads have been born and they are at your new stage. Okay, E1. And now, the moment I invoke start, it would go into the runnable state. So just say T.start and T1.start. That's fine. Now go to your employee.java. First of all, compile this and run this. Okay, and name your threads also, Ram and Sham. Or it's fine. If you do not name it, by default the name is as thread 0 and thread 1. So can you please compile this? Let's see what the behavior of your application is coming as. Let him compile. Javac test1.java, Java, test1. Okay, could you go up? Okay, so again, if you could see what would have happened over here, the time scheduler would have snatched the CPU, given it to other thread, and blah, 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 blah. So right now, if you see, we have gone this way, the life cycle of a particular thread. Now what I want that a blocked state should come. When a thread is blocked, there is no block method as such, okay? Whenever you say that your thread wants to sleep, or whenever you invoke a sleep method on a particular thread, the thread goes into the blocked state. So now what I want is, go to your Reddit plus, employee.java, the moment the thread, any thread, it can be thread 0 or it can be thread 1, the moment the thread finishes printing the I value, it should go to sleep or it should go in the blocked state. Okay, so after this line, just invoke thread.sleep. Thread.sleep. So any current thread, okay, the current thread which is executing this particular method on line number line, if the thread executes line number line, it will go into the blocked state, because you are forcing the thread and you're telling the thread, see boss, right now suspend yourself, don't do anything, you are supposed to sleep for some time. Now the time is to be given as a parameter to your sleep method, okay, and the time is always in milliseconds. So if now I want that my thread should sleep for 1 second, so I'm going to specify 1000 over here. That means 1000 milliseconds is making what? 1 second. So now whenever any thread comes over here, if it executes this line, after executing this line, the thread would sleep for 1 second. Now just look over here. Any thread, okay, I have started my thread, it is in runnable condition. Time scheduler is going to give the CPU to the runnable thread and it would be in the running position. Now when I am in the running position, what am I supposed to do? I am supposed to execute my run method. Now while executing the run method, I print the value of I. The moment I print the value of I will print or execute the next line, which is thread.sleep. So now whenever I am running or I am executing thread.sleep, I come from running condition to where? To the blocked state. Okay. Now the moment your current thread jumps from running state to the blocked state, what happens to the CPU? The CPU is empty. So what the time scheduler is going to do? It is going to take the thread, or it's going to take the empty CPU or the idle CPU and give it to the thread who is in your runnable pool. Okay. So now I take the CPU and give it to the runnable pool. Now when I come over here, when I get the CPU and I change my state to the running state, what would I do again? The second thread. Okay. Just keep in mind, the first thread is in a blocked condition for 1 second. 1 second is a big second, okay, it's 1000 milliseconds. So when I give the CPU is empty, I give it to the second thread. Now the second thread, what the second thread is going to do, it is also going to execute that line. It will print the value of I. After printing the value of I, what would happen? It has to execute thread.sleep. The second thread also is executing thread.sleep and it goes into the blocked state. Now, how many threads do I have in the blocked state? There are 2 threads, correct? Thread number 1 and thread number 2, or thread number 0 or thread number 1. There are 2 threads which are in the blocked state, and now the CPU becomes empty again. Now, do I have any more threads in my runnable pool? No. I don't have any thread. So what is the CPU going to do? He is going to sit idle for some time. Now what happens? The thread which had gone earlier in the state is going to get released fast. First in, first out kind of a service. Okay. So the 1 second of this particular thread is over. It's back to the runnable state. Now the CPU would say, oh boss, there is some thread in the runnable pool, I should quickly give that particular CPU to that thread. So it will give the CPU to the thread which is there in the runnable pool and it will jump over here and become running. Now when I am over here running, again I would execute the value of I and I would go into the blocked state. Now, when I reach the blocked state, what happened to the thread who was earlier? It must have also come over here in the runnable pool, because 1 second of that thread would also have been over long back. So now the CPU is empty again. It would check whether is anybody there in the runnable pool. Oh yes, the thread which I had sent to the blocked state has come back again. So I'm going to take this thread, give the CPU, it would be running. Again this would go into the blocked state. Now again both the threads are in the blocked state. And the CPU is waiting over here and saying when the thread is going to leave the blocked state and come into runnable, so that I can give the CPU to that particular thread. Who's saying that? The time scheduler. So what kind of a output are you guys visualizing? Thread comes here, then it comes here, it prints something, it goes to blocked state. Second thread is over here. It prints something, go to the blocked state. Now, in order to come out of the blocked state, they have to remain for at least 1 second in the blocked state. Okay? So now they are 1 second in the blocked state. My CPU is idle, just waiting. Okay? After my waiting is over, one thread would come over here. CPU is going to be given to that thread. It will become running. Till that time, the second thread will also get released and it will enter into the runnable pool. Again I will print something, again I will halt because there are no threads in the runnable pool. Now let's implement this and see the output, whether the output is coming same as what we have visualized. Okay, now compile all and run. Compile, no? Do CLS and compile it. Now just see over here. The moment you're trying to implement this sleep method, it's throwing an exception. What kind of an exception is this? Checked exception. So either you throw it out of your system or try to catch it. Let's throw it. Okay, so you say throws exception. Okay, you can't do that because run ka this thing will be violated, overriding. So you'll have to catch it only. So just catch it. We'll be catching this particular exception. In order to catch the exception, we are going to use our try and catch block. Sleep method throws interrupted exception. Okay, so just say E in stack trace. E dot print stack trace. See. Okay, the CPU is waiting over here and then printing. Why is it waiting? Because there are no threads in the runnable pool. All the threads have been gone to the blocked state. Till the time the first thread is not released, the CPU is just waiting for the thread to come inside the runnable pool. Okay, now if we give 2-second delay, can you go back and make it as 2000? So it would be more evident. Okay, now compile it. It's still working. Just okay, run the application. See, now it's waiting. Now this order would not change at all, Ram Sham. Why? Because Ram was the first one to enter the blocked state, first one to come out. Sham entered later, so later one to come out. Okay, so I just see, now whenever a thread is in the running position and it goes to the blocked position, after seconds are over, after 2 seconds of that particular blocked session, or if I am telling the thread to sleep for 3 seconds or 4 seconds or 5 seconds, those many seconds the thread is going to be in the blocked state. the moment the waiting period of the thread is over, the thread would come back to the runnable state. It will not go back to the running state. Okay? This is very important, guys, because many of you would say that, oh, the CPU only told me to go to the block state. I was running now first. Now, once I have finished my block state, or once I have come out of the block state, I will run again. It is not that case. You have to enter into the runnable pool, and then you have to wait for your chance to come so that the time scheduler gives you the CPU. Okay? So this is how, now it's still running because we have given 2 seconds delay. Now let's concentrate on the other methods. Okay? Now here you would have seen that whenever you have threads in your runnable pool, okay, the CPU picks up a random thread and gives the CPU to the thread which is there in your ready to run pool. Now the time scheduler over here who hands over the CPU to the thread in the runnable pool will not check, oh, which thread are you were working here before, no, or I had given you the thread just a few seconds ago, I won't give you later. Okay, all those things, or the principles or the criteria on which the time scheduler hands the CPU to a particular thread is not known. Any thread can work anytime. Okay, so right now just can you please thread sleep? Okay, thread.sleep, can you please comment it? I want to show them how the thread scheduler randomly gives the thread to, or randomly gives the CPU to the threads. Yeah, can you compile it? Now I'm not sleeping or anything, or it is not going through this particular channel. I'm just running the application. Okay, you'll have to, yeah. Just say /* to comment a block. Okay, and now if you would compile this and run the application. So now see, RAM was given a chance by the CPU to print only 38. Then I don't know what happened. The CPU was snatched by the time scheduler and it was given it to Sham again. So whenever anybody is executing, or the time or the amount which a thread executes, or the time or the amount for which the thread is in the running state is not determined at all. So suppose if you have an application which says that, here is my typical application. I have M1, I have M2. Okay, I am asking one thread to print or to execute M1. T is executing M1, T1 is executing M2. Okay, this is a particular kind of an application, and I am saying that only after T has finished its work, T1 should start. Okay, or T1 should execute M1. That means M2 should be executed only after M1 is finished. Is this possible? Because both of them are threads. Okay, now thread T is assigned M work, thread T1 has been assigned M2 work. I will show this in a particular example so it will be much more clearer. Now since these are two different work, okay, it can be different also, it can be same also. Let's make it as same. I've got two threads which want to execute M1, but I am saying that till the time T has not finished its execution, T1 should not start. Is it possible? Just think about it. No, it is not possible. We have seen over here, whenever I say T.start and whenever I say T1.start, the CPU is being given to any one of the thread, either T or T1. Okay? If I start T1 first and T later, it would not help me. Just let's try and do this. Now my application is that T should finish and then only T1 should start. Okay, T is doing the same work counting from 1 to 50. T1 is doing the same work counting from 1 to 50. Both of them are doing the same work, but my requirement is till the time T does not complete its counting, T1 should not start. Is it possible over here? Here I am counting. Here is the run method. Okay, go back. Save it, no? Save employee. Okay, go to your test one. I am saying T dot start and T1 dot start. Okay, I am starting T1 later, I am starting T earlier. Then to this particular then to the output, that is first T should count, then T1 should count is not guaranteed. T is counting, then in the middle T1 is getting the CPU, then we have got one method called as join. Okay, so what I'm going to say is after T dot start, I'm going to say T dot join. Okay, now let's first execute this, then I'll tell you what happened and what is the effect of join. So now let's compile the application and run it once more. Again, join throws an exception, so you should have a try and a catch block. Oh, it's in a main, no? So you just say main throws exception. So now you would see that the moment what is our requirement? T should finish and then T1 should start. So now in order that T should finish and the CPU should not disturb them in middle, I have invoked join on T. Okay, now let's have a look at the output which we got. T is who? Ram. T1 is who? Sham. So now just look at the output. Beautiful, it has come. Okay, I started my application and what would have happened? T dot start must have got executed and then T dot join. The moment you invoke the join method on a particular thread, on which thread did I invoke join? I invoked join on RAM. That is nothing but thread T. The moment you invoke join method, you are telling your CPU to halt. You are telling CBOS time scheduler, you should halt right now and you should not do this swapping. Till the time I don't finish the execution of my complete thread and I do not become dead, you will not swap anything or you would not give this to anybody, and the CPU or the time scheduler halts for that much of time till the time the thread does not go into the dead state. Okay, so if you want that a particular thread should first finish all its work and then go to the dead state, and then the CPU should be to any other thread, so you are supposed to invoke join on that thread only. What was my application? I wanted that T should finish its and then only T1 should start. So what did I do? I started my T, then I called join on my T. That means till the time T does not finish execution, I don't want T1 to start. After the thread was dead, then I started my T1. Okay, can you please go to the API and let's see what does join method has to say. Thread. Okay, go to the method. Now here, come down, and there is a method called as join. Okay, waits there for the thread to die. Okay, join is also there with millisecond. Okay, it's staying, waits at most those many milliseconds for this thread to die. If the thread is not dying till that particular time, it's going to give the CPU to somebody else. Okay, now there is one more method left which is called as yield. Okay, Now, before talking about the yield method, I would say that let's talk about priorities. Do you have priorities in threads, and how does it work, and what do you mean by priorities, and blah 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 blah, all that stuff. Okay. So suppose you have created two threads, okay, doing the same work again or doing different work, it does not matter at all. Okay, you have T and then you have your T1. You start your T, okay, then you start your T1. Now I want to say that even if T is working, I want the T should stop it and then give T1 or allow T1 to proceed, which means if my thread has got a priority called as medium, okay, if the current running thread has the medium priority, in the meantime, if a thread with the higher priority comes in this particular pool, that is ready to run pool, what happens is time scheduler is notified, okay, and then what he would do, he would snatch away the CPU from the current running thread and hand over the CPU to a thread which has got highest priority. So there is a rule in Java which says that if a thread of higher priority enters into ready to run pool or enters into a runnable state, then the CPU is snatched from the current running thread and it is given to the thread of higher priority. Now who decides whether the priority of the thread is higher or not? It is checked with the current running thread. Okay, if the current running thread has got medium and if the current running thread has got priority called as 5, and if the thread who has come has got the priority 8, means the thread who has come has got higher priority than the thread which is actually running. Okay, now you would say that how do we set the priorities on a thread? There are methods to set the priorities on the thread. First, understand priorities, then we will set the priorities on the thread and see what is the reaction. Now whenever you are talking about priorities, it has been scaled from 0 to 10. 0 being the minimum priority, 10 being the maximum or the highest priority. The middle thing is 5, okay, which is the normal priority. Whenever you create threads and at that particular time you don't set any priority on thread, by default all the threads have normal priority. That means they have the priority set to number 5. Okay, so now what I am going to do is, we'll create a particular thread and then set priority on that thread. Okay, let's go back. We have got two threads over here. Test one way. Move this way. Okay, now all the things which you want to do with the thread, that is setting the priority, setting the name, all those things you should do before starting the thread. Please make a very important note on this. After starting the thread, you don't have any control on the thread. Before starting, you should do all the things which you want to do. So after line number 8, okay, write T dot set priority. I'm going to set the priority as minimum. Okay. Set priority as 0. That is the minimum priority. Okay. And then I would say T1 dot set priority as 10. Okay, go up. Yeah. Just make it over here only. T1 dot set priority as 10. Okay, so now who is getting started first? T is getting started first. Okay, that means the thread which has got lower priority would enter the runnable pool and then would get the running state. Now see, join does not work with priorities at all. If you are talking about priorities, then you should not use join. Okay, comment this out, line number 12. Join is for a different purpose altogether. Okay, now I am starting my T and then I am starting my T1. Okay, what should happen? What should happen? The moment T goes over here, okay, it is running. T1 enters into the runnable pool. The CPU comes to know that, oh my god, a thread with higher priority is over here, so it will give the CPU to the thread T1. That is, it will give the CPU to Sham. Now till the time a thread with not as higher priority as Sham has entered into the runnable pool, it will not get the CPU. That means first Sham will complete and then Ram is going to, after Sham will complete its run method, it will go into the dead state and then Ram is going to get the CPU. Can you do CLS and then? Okay, make it as 1. It's from 0 to 9, I guess. Set the priority as 9 over here. Save it and run the application. Yeah, it's from 0 to 9. No, it's not even 9. Go back. Okay, make this as 10 and make this as 1. Yeah, make this as 1. Okay. Okay, so now let's see the result. Go up. Okay, Ram was working. Okay, then suddenly Sham entered. Sham is the one with the highest priority. Okay, it got the CPU. Then again Ram came. Now you would ask me, ma'am, Ram is having the lowest priority. Highest priority is who? Sham. Okay, now when Sham is running, nobody should come and interrupt this particular Sham because he has got the highest priority, right? But when it comes to priorities, very little is guaranteed. Okay, so whenever you can set the priorities, but the entire application or the output of your application or the logic of your application should not be dependent on priorities at all. That is even mentioned in whatever book you pick up and you talk about threads, they would say, please don't rely on the priorities. You can set it, but don't see or don't consider it as a holy grail and then create your application. So the rule for this priorities is whenever a higher or the highest priority thread enters into the runnable pool, the CPU is given to that particular thread. Okay. Now, when the threads are of equal priorities, that means Ram has also got 10 and Sham has also got 10. Okay. In this particular case, what would happen? Theoretically, okay, see, Ram has entered over here, Sham has entered over here. Now Ram is running and running and running and running. But Sham has also got the highest priority. Now what would happen over here? Ram would not give the CPU and Sham is also waiting with the highest priority. Then, in order to give up the CPU voluntarily, what happens is, whenever there are two threads of the same priority, the CPU or the time scheduler gets confused as to whom should I give the CPU. Okay, in that case, what you can do is, you can ask the thread to voluntarily give up the CPU. Okay, now what is usually happening? The time scheduler is snatching the CPU from the thread which is running. Instead of that, you can ask or as a thread, you can say, okay boss, I do agree that a same priority thread is waiting for the CPU. I voluntarily want to give away my CPU. Now, in order to voluntarily give your CPU to the time scheduler, you have to invoke the method yield. Okay, let's go to the definition of yield. Let's go to the API. Can you just see yield? It would be the last. Okay, causes the currently executing thread object to temporarily pause and allow the other threads to execute. That means I am pausing over here and I am giving away the CPU to other threads so that they perform their task. Okay, now you've got to be very clear, or this is a very confusing state. When I give up my CPU voluntarily, or when yield method is executed, your thread would not go in the blocked state. Your thread has voluntarily given the CPU and it would go back to your runnable state. It would not go like this, but it would directly go like this. Okay, so now what we are going to do is go to edit plus, make the priority as 10 of T also. Yeah, now both are same. Okay, now go to your employee. Here just say if, make an if condition for all multiple of 5. Okay, if I modulus 5 is equal to 0, it would never be 0. If all, correct. For all multiples of 5, I am going to give away my CPU, which means if Sham is executing from 0 to 10, whenever 5 comes, RAM is going to give away the CPU. The moment the RAM is going to give away the CPU, it's going to be consumed by Sham. So whatever be the output, at each multiple of 5, you would see the CPU has been interchanged, or the CPU has been exchanged by the threads, because they are giving away their CPUs. Okay, so right over here, current thread, thread dot current thread. Just check whether yield is a static method. Yeah, it is a static method. Okay, so you can directly say thread dot yield, just like your sleep. Yeah, thread dot yield. Very good. Okay, so every time at the multiple of 5, I'm going to enter over here and give away my CPU. If I am RAM, I'm going to give away the CPU, and Sham is going to take away the CPU. So can you please execute this now? So compile and then execute. Okay, go up. See, 0, 0, whatever this interaction is, I really don't care. But it is not entering inside this then. Something is wrong. Okay, now earlier we were not getting the output because we compiled test before employee. In employee we did all the changes, okay? So the changes did not take any effect. Now we are compiling employee first, then we will compile our test first, and then we will run the test. Yeah. Now you would see go up. Again, it's not. How come go up? Wait. Okay, now let whatever the output is, whenever 5 comes, the context is taking place. Now here 10 comes, Sham was having it, then Ram got it. Okay. Now wherever the multiples of 5 are, 10 came over here, Ram was executing it, then Sham got it. Okay. Come down. 15. What is 15? 15 is over here, Sham had it, then Ram got it again. Okay. So wherever you can see the multiples of 5, you would see the context is changing from Ram to Sham or from Sham to Ram. This is because whenever we have laid the condition, go to employee.java, we have laid the condition that if I modulo 5 is equal to 0, whichever the current thread is, after printing it, after printing 10, I am going to come over here and see if I enter over here, or if I am a multiple of 5, then I am going to give away my CPU. So after printing 10, you would see there would be a context change. Go back to your see, 10 multiple of 5, yes, context has changed. 15 multiple of 5, yes, context has changed. 20 Sham, then the context has changed over here. So what does yield do? whenever a yield method is called on a particular thread, it voluntarily gives away the CPU to the time scheduler and goes back into your runnable state. Okay, so with this we would end our threads. We are not completely ending our threads. There are a few more topics which are left yet to be covered, but the basic threads as to how to create it, how to invoke start, what does your run do, what does yield do, what does join do, what does sleep do, all those things are covered. Now in the next class, we would be seeing how to create a thread using your inheritance. And secondly, we would be talking about daemon threads as well as thread groups and synchronization of threads. Okay.